A long john antenna is a highly directional Yagi-Uda beam antenna characterized by an exceptionally long boom. Though originally an antenna from a specific manufacturer, the term is often used generically by radio operators to describe any extended boom Yagi. Why long boom matters? In antenna design, simply adding more direct elements to a Yagi doesn't automatically increase its power. The primary factor that determines a Yagi's maximum forward gain is its physical boom length. By spreading elements across a massive boom, a long john antenna achieves several performance advantages. Massive forward gain. They tightly focus the RF energy in a single direction, often achieving an actual forward gain of 8 to 11 decibels, making a 100-watt transceiver punch like a much larger amplifier in that specific direction. High front-to-back ratio. The spacing of the reflector and directors aggressively cancels out signals arriving from the rear, often providing 20 to 30 dB of rejection. This is crucial for isolating weak DX stations from heavy background noise. Mono band efficiency. Because they are designed for a single band, they don't use LC traps, that is inductors and capacitors, to achieve multi-band resonance. This eliminates the power loss and narrowed bandwidth associated with trapped antennas. Matching system. They typically utilize a beta match or hairpin match at the driven element to ensure maximum energy transfer to a standard 50 ohm coaxial feed line. If you double the number of elements on the same length boom, the gain barely changes. To gain an additional 3 dB of forward punch, you generally have to double the boom length. Because element length and boom spacing scale directly with wavelength, a long john is a massive piece of hardware. A 4-element long john for 20 meters has a boom length of 26 feet and elements over 36 feet long. Attempting to build a long john Yagi for the 80 meter or 160 meter bands is physically prohibitive for almost all amateur installations. The boom would need to be hundreds of feet long to achieve the optimal spacing, requiring commercial broadcast level towers. This is why you mostly see long johns deployed for 20 meter, 15 meter, 10 meter and VHF UHF operations, while wire dipoles, slopers and vertical arrays remain the practical kings of the lower HF bands.